So we're going to talk a little bit about regrouping. So the first thing you need to understand is that any whole number can be rewritten as a sum of smaller numbers. So for example, 6 is the same thing as 5 plus 1. Pretty easy, right? Well, that's the same thing as 4 plus 1 plus 1, which is the same thing as 3 plus 1 plus 1 plus 1, etc. We can just keep writing this over and over and over, and we can see that 6 can be written as the sum, ultimately, of 6 ones. Okay, so if we can understand this with whole numbers, let's transfer this understanding to fractions and whole numbers. So let's say now we have 6 and 2/3. So 6 and 2/3 is the same thing as 6 plus 2/3. So that's the first thing we need to understand. Well, we saw up here that 6 is the same as 5 plus 1. So 6 and 2/3 could be 5 plus 1 plus 2/3. Now that can come in very handy when we're regrouping. So we could rewrite 6 and 2/3 as 5 plus 1 plus 2/3. Now, 1 can be rewritten as 3/3. It could actually be rewritten as any number over itself, but since we're dealing with thirds because of the 2/3, we could rewrite the 1 as 3/3. So therefore, 5 plus 1 plus 2/3, which is 6 and 2/3, could be rewritten as 5 plus 3/3 plus 2/3, which is still 6 and 2/3. Now, I could take the 3/3 and the 2/3 and add them, and I would get 5/3. So now I could end up with 5 plus 5/3. So we know that 5 and 5/3 equals 6 and 2/3. So I'd like you to try a problem. Let's say we have 8 and 1/5. I would like for you to rewrite that as 7 plus 1 plus 1/5, and then you're going to fill in the question marks. What could 1 equal to help us regroup here? And then what would we get as our fraction with 7? So pause and see if you can figure out the question marks here. So you should end up with 7 plus 5/5 plus 1/5. What we're doing is we're replacing the 1 whole with a number over itself. And the reason we're picking 5 over 5 is because the denominator we're working with is fifths. So 7 plus 5/5 plus 1/5 is the same thing as 7 plus 1 plus 1/5, or 8 and 1/5. Okay, so let's keep going. So now we're going to replace this question mark by adding the 5/5 plus the 1/5. So we get 7 plus, and I'm just going to show an in-between step here, 5 plus 1 over 5. Just to remind us, when we have common denominators, we add the numerators and we keep the denominators. So that's 7 and 6/5. Let's try another one. This time, let's try 4 and 2/7. Okay, so 4 and 2/7 is the same as 4 plus 2/7, which is the same as 3 plus 1 plus 2/7, which is the same as 3 plus, I want you to put a fraction in the place of 1, plus 2/7. Then I want you to add those two fractions together and then tell me what we get when we regroup. So pause the video and give that a try. So you should end up with 3 plus 7/7 plus 2/7. So we are replacing the 1 whole with 7/7 because any number over itself equals 1 whole. Now we're going to add the 7/7 plus the 2/7. And I'm going to show the in-between step here, which is adding the numerators and keeping the denominator. So we end up with 3 plus 9/7, which equals 3 and 9/7. So 3 and 9/7 is equal to 4 and 2/7. Now let's look at that a little bit more deeply. So if we look at 3 and 9/7, we know that the way you change an improper fraction is by dividing the denominator into the numerator and seeing what you have left over. So let's divide 7 into 9. When we do, we get 1 whole minus 7. There's 2 left over. And the remainder of 2 goes over the 7. So 9/7 equals 1 and 2/7. So if we have 3 and 9/7, that means 3 plus 9/7. And we just saw that 9/7 is equal to 1 and 2/7, which is the same thing as 1 plus 2/7. 3 plus 1 is 4, and 4 plus 2/7 is 4 and 2/7. And that's where we started at the very beginning.